tell me the answer to this question. Can people like me and you, can we predict the future? In a way?
Depends upon what we're predicting.
Let me ask you a question. If you could predict the future, what would you be doing?
Going to Vegas.
I would be going to Vegas, or I'd be going down here to the Sphinx down here. Why?
Get a lottery ticket.
Get a lottery ticket. So anybody that says they can tell the future, all you need to do is ask them to what? Give you the lottery numbers. That's the best way to shut them up. Because nobody can predict the future. No one. No human being, that is. Now there's probably entities that people worship that can. And I say that to cover all bases. I don't want anybody, the ACLU coming in here and saying that I said any certain one. But there may be some entities that people worship that can tell the future. And that excludes all of us in this room and anybody else walking out there in the parking lot or anybody walking down the hall. You can't tell the future. But you can put a number on a prediction. And when you put a number on a prediction, that's what's called probability. Usually, I just like to give this story because it happened to me yesterday. I went down to Walterboro yesterday to pick up a board. And yeah, you're going to have to Google it. Some of y'all have no idea what a board is. But anyway, those of you that don't Google it, B-O-A-R. I went down there to pick up a board. Now, some of y'all know where Walterboro is? Yeah. It's right down there near dang old Charleston. And I went the back way because I wasn't sure how my cattle trailer, or livestock trailer, would operate all that way down because it does have some age on it. Well, it did okay. But anyway, I got down to about, I don't know, Edgefield or McCormick or whatever, wherever I was down there. And I was on this 2-lane road. And this 2-lane road, with GPS said dang old 52 miles or whatever. And I was on this road for 52 miles or however long it was. And I was behind a little blue-haired old lady. Going like 44 miles an hour. Wouldn't go 45. But it goes 44 miles an hour. Now some of y'all have got in this situation going down Wild Hog Road, going to Pendleton. Wild Hog Road is the worst. Especially if you're going to 8 o'clock class and it's 7:30 and you're trying to get there and you get behind a little blue-haired old lady right there at Garrett's and you stay behind her all the way. But anyway, I was behind this lady at 44 miles an hour. She had that sucker set on cruise at 44 miles an hour. Got to the end of the road because you had to either go left or right. I had to go left. I told the person that was riding with me, I said, I bet you $100 bill she's going to turn left. No, she could be turning right. I said, bet you $100. No, I'm not going to take that bet. Just as soon as she said that, her left blinker turned on. I just told the future. Oh my gosh! Go to the lottery. Let's go win the lottery. Did I tell the future or did I predict? I predicted. There's a little bit of difference. There's a fine line between them. Now, how did I know that? Because I've done my share being on Wild Hog Road as a student going to Tri-County Tech, as a student going to Clemson, and as a teacher going to Tri-County Tech for 15 years of my 19 years at Tri-County Tech. So I've got a little bit of data. Not that I sit there and wrote it down every day. Just memory data. And I know, and another thing, if you're on Wild Hog Road and you're going toward Pendleton, are you going to take a left or are you going to take a right when you get to the end of Wild Hog Road? Left. Most people that are on Wild Hog Road, if they're heading that way, are not going to Sandy Springs. So you know that that person's going to turn left because of memory, because of you're running late, and because you're on the road to Pendleton. So, anyway, to make a long story short, probability, and there's all kind of mathematical definitions. Probability is basically, I done forgot what I was going to put. Assigning a number to a prediction. Now, when I was on that road and I got behind 44 miles an hour, I told the person I was riding with, I said, I'll bet you $100. Okay? Of course, you could do that every time you make a prediction, or you could say, I've got a certain feel that that person is going to turn left, or I've got a certain feel that this person's going to stop, or whatever the prediction is, and that is probability. And that number is between 0 and what? 1. Now, somewhere in your book, in the margin or wherever, there's going to be a little pre-shaded arrow, and it's going to be from 0 to 1. That's the scale of probability. Now, let's put probability right out here to the right. And then 0 to 100%. That's what some people call it. But that's more of chance. Now, this is where there's two types of probability teachers. There's a probability teacher that teaches you the probability, the van, and we go on down the road. Then there's the probability teacher that eats, drinks, and sleeps probability. Now, if I asked you what's the probability of that person turning left, and you tell me there's a 50% chance, I'm going to say, okay, yeah, you're right. 50% chance she's either going to turn left or right. You have a probability teacher that eats, drinks, and sleeps this stuff, they're going to say, that's incorrect. It's really 0.5 probability. You got some teachers that believe that this is the only way to speak of probability. Point system, the decimal system. 0.75. 0.25. There's a 0.25 probability that that car will stop in the middle of the intersection. But if you say there's a 25% chance, that teacher's going to say, that's really incorrect. I don't care. All right? Just make sure you know that some probability teachers will have a cow and put a percentage on that probability. They want you to say it in terms of a decimal. All right? Not a big deal, but just make sure you make a note of it. All right? So if you walk into a Stats 301 at Clemson, which is called Math Science 301 Business Probability or Probability in Business, make sure you don't go in there and say, well, there's 50% probability. Don't do that, because then you're going to open up a can of worms if you get one of these eat, drinks, and sleeps statistics, okay? Just telling you. Now, what's 0.5? Well, this is unlikely. This is more than likely. Well, then what do you think 0.5 is? It's right there. It's likely. It's in the middle. Likely. I don't know. Look at your little arrow. It's somewhere in there. It'll have likely or somewhat likely or something like that. Now, in chapter 6, we're going to do the probability under a curve. And I told you this the other day. You've got to relate the probability to a gas tank or a fuel indicator. And we know that this is about 0.25. This is about what? 0.5, 0.75, and on. And you're going to get the area under a curve in chapter 6. Okay? In this chapter, we're going to talk about just probability, period. We're going to talk about how to find it, or how to calculate it, what it means, and how to apply it. Because so far, all you've talked about in here is how to do numbers. That's all you've talked about. Let's look at some terms that is in your book, and I'll tell you if they're important or not. I talk about the Mayberry probability and the fiscal probability. They call it theoretical and all this other stuff, but I'll just turn there. I think it's 4.1, 4.2. 4.1 is just reading. You know how much it got up to yesterday, temperature-wise yesterday? It's like almost 70 degrees.
Really?
Yep. Tomorrow it's going to be like maybe 15. Isn't it going to be a milk and bread week?
Oh, yeah.
Everybody's going to run around.
Milk sandwich.
Yeah. Everybody's going to be running crazy. News Fluffy 4 is going to do its job. Winter Storm 2015. Let's see. I ain't talking about probability. I'm trying to find the Mayberry probability. Simple event, sample space. Sample space. Make sure you know what a sample space is. Sample space. If a couple has two children, two babies, two kids, whatever, or they're pregnant and they're expecting twins, what is the probability that they're going to have blue eyes? Or what's the probability one will have blue eyes, one will have brown eyes? Or one will have brown eyes, one will have blue eyes? Or one will have blue eyes and blue eyes, or brown eyes and brown eyes? Notice I just said the sample space. I said blue eyes, brown eyes, blue eyes, blue eyes, blue eyes, brown eyes. That's the sample space. So when you're talking about babies or you're talking about a birth or whatever, you can make a sample space by the writing out of the possibilities, and that is right here. These guys right here are sample spaces right here. We're going to do some of those. There we go. Relative frequency and classical frequency. Whatever. Let me just go ahead and explain this, because a lot of people go through probability and statistics and they talk about the relative frequency and the classical, but they have no idea what it is. There's two types of probability. There's the Mayberry probability and there is the fiscal probability. What's the Mayberry probability? What is Mayberry? Huh?
Somewhere in Raleigh?
Yeah. It's a made-up town after Mount Airy, North Carolina. But why do people watch Andy Griffith? Why do people watch it? Why is there 3 trivia games on it? Why is there 4 trivia books about it? Why is there nuts like me that can tell you all about Andy Griffith? Why? What is the obsession with it? Why is it popular? That's why I'm asking. Why is it so popular?
It was funny.
It was funny. Well, there's a lot of funny shows. There's the Cosby Show. But you don't have 3 trivia games about the Cosby Show. You don't have a trivia game about the Brady Bunch. At least I don't know of it. You don't have a trivia game about, what's another comedy show? I ain't going to mention any of these that are on TV now because they're stupid. I mean, I could write a comedy show based on what I see today, so I don't even watch them. But I Love Lucy. Is there a trivia game on I Love Lucy?
Pretty sure there is.
Is there?
Yeah. I Love Lucy.
Well, it sucks. I hate I Love Lucy. Can't stand that show. The apartment always looked dirty. I just don't like that show. But anyway, why is there 2 or 3 trivia games about Mayberry? Because it was a modern day what? Utopia. Why? What's a utopia? Some of y'all are going to have to Google that.
Perfect society.
Perfect society. Why? Why was it perfect? There wasn't no crime, just a couple of drunks every now and then, and a couple of bootleggers, and a couple of people that wanted to...
Occasionally the criminal, though.
Occasional. There wasn't no terrorists. There wasn't no this and that. There wasn't, this woman getting blown away by this caveman. There wasn't the caveman getting run over by this woman. There wasn't anything like that. Why? Why? Because it was perfect. So when I say Mayberry probability, that is the probability that we calculate and put in the book it should be. I'll give you an example of Mayberry probability. Mayberry probability is what we calculate should be the probability. Example. The probability of picking a king in a deck of cards. Somebody tell me what that is. Well, it's the number of events that happen over the number of events that it what? Could happen. How did I know that? Well, there's 4 kings in a deck of cards. Some of y'all have no idea what I'm talking about. Well, if you want to pass this next Unit 2 test, you're going to have to learn about the deck of cards. There's the easy way and there's the hard way. Hard way is going and buying a deck of cards and trying to memorize everything. The easy way is finding a little system. You ever heard about the soldier's prayer? Okay, before I show this, I'm not trying to convert anybody to any type of religion. I do not need the ACLU coming in here saying that I'm trying to convert anybody. We're not going to pass around the offering plate. All right? But there is an old story that people write songs and poems and all this stuff. I don't know what you call it, but anyway, it's called the Soldier's Prayer. Deck of cards. Deck, cards, Soldier's Prayer. No, I didn't make it up because there it is. Okay? And you can look it up. Deck of cards. There's in here somewhere. You just have to look it up. But anyway, let me just do the images. It's a whole lot quicker to do it that way. Well, y'all just have to find it. But anyway, it tells about the different deck of cards and how people memorize the deck of cards. Where is it? There it is. Right there. And it talks about, let's see, how many weeks of the year is there?
52.
And how many decks, how many cards are in deck cards? Okay? How many suits are there? And then it talks about, that 4, and this is part of the Bible. Okay, that's as far as I'm going to go. The Bible is a book, okay? Don't want the ACLU knocking down the door. So, if you ever want to learn the deck of cards, that's a good way to learn it. Or you can try to memorize it, however you want to. Okay? Now, the reason I'm showing you that is there are a lot of questions in your homework and test about the deck of cards. So you might want to learn, if you've never picked up a deck of cards or never played a single game of poker or rummy or whatever, then you might want to look into that. Now, what if I ask you about the probability of a face card. Alright, well, again, if you don't know the deck of cards, you don't know that there's 12 face cards. How do you know that? Well, there's the Jack, there's the Queen, and there's what? King. And how many suits are there? 4. 4 times 3 is 12. So the answer would be 12 over what? 52. Now, somebody take your handy dandy calculator, and I know they can be reduced, and that's fine, but I want you to tell me, just give me 2 decimal places. What are those 2 numbers? What's the first one? 4 out of 52 is what?
0.08.
0.08. Or 0.1. What's 12 over 52?
0.23.
0.23. Or 0.2. So would you put $100 on either one of those bets? No, but would Vegas have a game for that? Yes. Why? Because the probability is so what? Low. Alright, now, the Mayberry probability is what Vegas uses for their odds. What the Mayberry probability is based on the deck of cards. They're not going to go with what's happening, what the physical probability is. Either way, the Mayberry probability or the physical probability is the number of events where it happens over the number of events that it could what? Happen. Now let's think about that. The face card, the king. How many cards are in a deck of cards? 52. So that's the number of possibilities it could happen. Okay? There's 52 cards. So you lay those 52 cards out on a table. One of them or 4 of them, you're going to pick one at a time. You're not going to pick 4. Alright? You're going to pick one at a time. Those 52 are your possibilities. No matter if you pick 1 or 2 or 3, the 52 stays 52. Because that's the number of possibilities. Now, how many do you pick? Well, that's up to you because we're getting into physical probability when you're actually picking them. But we know that there's 4 in the deck and there's 52 in the whole deck. So that's where we come up with that. Whether it's physical probability or Mayberry probability. Mayberry probability is based on how many face cards, how many kings, how many queens, how many whatevers, and how many are in the deck. The whole deck. Well, what's the physical probability? Physical probability is what we actually do with a deck of cards. In other words, let's say you go and buy a deck of cards and you want to test the Mayberry probability and you want to draw 10 times out of a deck of cards. So you shuffle them up and you put them on the deck and you spread them out and you pick one card. Alright? And you get a 10. So let's do 10 times. First time you get a 10. You shuffle it, put the 10 back in, you shuffle them up. Second time you get a 2. You shuffle them up. Third time you get an ace. Shuffle them up, spread them out, you get a king. Shuffle them up, spread them out, you get a 3. Shuffle them up, spread them out, you get another king. Shuffle them up, spread them out, you get a ace. Shuffle them up, get a 9. Shuffle them up, get a 2, shuffle them up, you get a 4. So what's the probability here? 2 over what?
15.
Which is equal to point what? I'll say the fiscal probability don't equal the Mayberry probability, because the Mayberry probability said you were going to get what? 0.08 or 0.1, right? Well, so what's the problem? Well, fiscal probability is always going to be different from the Mayberry probability. All right? Why? Because that's what makes up probability. There's a thing, I don't know if it's in your book, they used to put it in there. The rule of large numbers. See if it's in your book. Somebody look and tell me. It should be in one of those first couple of 3 sections.
Yes, sir.
Page what?
137.
Page 137.
It's in the law.
Okay, law of whatever. Page 137. And it basically says that the more trials you attempt, the closer the probability, the Mayberry probability, the fiscal probability is going to get to the Mayberry probability. There was a book about several editions back. What edition is this one? Might look. What edition do y'all have now?
It's 12.
12. This was like the 8th or 9th edition. And they had the law of large numbers, and they had a whole page about the law of large numbers. And it talked about how this one college, these students took a computer program and wrote a computer program to flip, to take a coin and flip it infinite number of times. They took, what they did is they measured this coin, they measured its density, and they measured its width and height and whatever, and how much it weighed, and all these other, and they flipped it like 15 times, and they took time still photographs to figure out this and that, and they did all this stuff. And they took all that stuff and they put it into this computer program. And this computer program would flip it. I guess you'd call it in virtual space or whatever. And they could just type in however many times and it would tell how many times it would fall on heads and how many times it would fall on tails without actually flipping it. Because they put all the data in there about the coin. Well, they found out that what is the probability of getting heads on a coin? Point what? 0.5. They flipped it 10 times in that computer, and it was like 0.07 or 0.0 whatever. It was some crazy number. I wish they kept it in the book, but they didn't. Then they flipped it 100 times, and it went to point so and so. And flipped it 10,000 times, or 1,000 times, and then 10,000 times. And then eventually they got it up to 100,000 times, and they flipped it in the computer program 100,000 times. And when they got it up to 100,000 times, the probability of tails was around 0.4955 repeating, something like that. Okay? Now, who cares about flipping a coin 10,000 times? Nobody. All right? But what does this say? This says that if you're conducting some kind of research, let's say that you're working for Michelin, and you're a supervisor or you're a director or whatever for Michelin, you're up there in Greenville at the Crystal Palace. You ever seen it up there on the left going to Spartanburg? That big old, we call it Crystal Palace when we would go by there. But it's this big old 5-story building. It's got the Michelin. You know. Well, anyway, you're working there, and you're a director, and you make 6 figures. 70 to 150,000, somewhere around there. Making the money. And one of the big honchos of Michelin is in some other Crystal Palace that makes more money than you, says, I want you to tell me blah, 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 about this tire, blah, 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 blah. All right, how much money do you make? You make $70,000 to $150,000. Are you going to go and do some research on about 5 or 6 tires and then report that at the next residents meeting? Yes or no? No. Why? Because you're going to get your butt what? Fired. Why? If you're making $70,000 to $150,000 a year, and somebody, and the director or the president of Michelin, comes to you and asks you to do a report on this certain tire, you're going to go out and you're going to get at least a good reading of what the nation uses, and you're going to get a reading of how much tires you put out. You're going to, how much is used in Europe, how much is used in Asia, whatever the case may be. You're going to get all these numbers. You're not going to walk into that report saying, oh, Anderson used so-and-so timing tires and they got 15 wrecks and liability of this and this using Anderson. That ain't going to pull it. That ain't going to do it. So what the large number rule is saying is basically if you're doing some research and your paycheck relies on it or your job relies on it, you better make sure you have what? You've done your homework. In other words, you've done a little bit of, repetition, or you've done a little bit of research, or make sure your numbers are valid. All right? That's what the large number rule is saying. Okay? All right. So, the Mayberry probability is basically the theoretical probability. Somebody make sure I spelled it right. And then the physical probability, it's basically the probability that you get when you try out the actual experiment. Both of them is the number of actual events that occur over the number that what? Can occur. Let's try a little experiment. See if I can find it.
What did you say the actual was? Mid-range theoretical and actual is what?
It's the number of attempts the number of something that actually happens over the number that can happen. Dang old math tool, dang old dice roll. Dang old gambling in class. Yeah, Mr. McClure was gambling in class today. Just wanted to tell you so he could get in trouble. Yep, we're going to bet.